This is the Methods and Measurement Lecture 2017-07-12, Section 3, Proportions. There are several kinds of proportions that chemistry students need to understand. The first one is direct proportions. Two quantities are directly proportional to each other if dividing one by the other gives a constant. So you have these two quantities, we'll call them y and x, and you're measuring both of them, and you notice that as y increases, x increases by the same proportion. We would say that y is proportional to x. This is an example of a direct proportionality. Data that's directly proportional would look like this. Here we have 5 different samples of aluminum, and each time we measured the mass and the volume. Now, when you analyze this data, hopefully you'd notice that as the mass increases, so does the volume by the same proportion. Now, mathematically, another thing that happens here when you have a direct proportion, which is related, of course, is that the two quantities, the mass divided by the volume, that ratio is always pretty much the same. Now, if you were to graph these values with the mass on the x-axis and the volume on the y-axis, you would get a straight line. And it's important that you can identify that if you graph data with a straight line, it's a directly proportional data, or if you have directly proportional data, you would know that you could graph it as a straight line. Alright, so key here, the quotient, which means dividing the two values by each other, is a constant. Another example of a direct proportionality might be that there's a relationship between how many hours you study your chemistry and the grade you get on the test. You would hope that that would be directly proportional up to a point. Alright, the second kind of proportionality is inverse proportionality. And two quantities are inversely proportional if their products are constant. So here we have two values, y and x, or two quantities, y and x, and we notice that y is proportional to 1 divided by x. Data that's inversely proportional would look like this. Here we have several cases where we've measured the pressure and the volume of a sample of gas, and notice something here. As the pressure increases, the volume decreases. That's what we mean by inversely proportional. And mathematically, this can be represented by the fact that multiplying the pressure times the volume gives you a constant value. When you graph this with pressure on the x-axis and volume on the y-axis, you get this shaped graph, which is known as a hyperbola. It's important to remember that name, and to remember this is how a graph of an inverse proportionality would look. Alright, so the product of the values is a constant here. An example of an inverse proportional relationship is an important equation that we use in chemistry and also in physics, that c, which stands for the speed of light, is equal to the frequency of a particular electromagnetic wave times the wavelength. That's an example of an inverse proportionality. Alright, that concludes this lecture.